I'm writing population. All of you, do you have a clear idea about the term population? Do you know what does it mean?
Total number of events.
Wow, great. Total number of events. Very good. Any other definition for population? All right. Let us say I want to study the buying behavior of people. Buying behavior of people. I'm typing something. Oh, it's not coming. Yeah, it's coming. So buying behavior of people in the age group of, let us say, 25 to 45 in Chennai. So right now I am trying to study the buying behavior of people in the age group of 25 to 45 in Chennai. Can somebody tell me how many such people might be there in Chennai? People in the age group, right? So I typed something. Come on, how many might be there? I think, please, feel free to unmute and speak.
Say about
I think
50%, 45 to 50%.
Percentage, okay. I'm just asking the numbers. It
Exact
can be
numbers.
any guess. It can be in millions or
Okay.
whatever number. Some approximately, just
Some
suppose.
3 millions.
Okay. So madam is saying 3 millions. Why it is very slow? I'm typing 3 millions. So this 3 million people, 3 million people are there in Chennai in the age group of 25 to 45. These 3 million people are collectively called as now population. All of you understand? I am trying to understand this group of people. And there are 3 million people in a particular city. And this 3 million people together, is called as a population. A set of 3 million people is called as population. Now, you wanted to study their buying behavior. Now tell me, will you conduct a survey with all the 3 million people? Is it possible?
No.
Not possible.
So you will probably limit your study to a specified number of people. Am I right? To a specified number of people. And particularly you will have some kind of data collection plan. I am writing here data collection plan. That is why you have discussed this in step number 4 in measure pace. So what is this data collection plan? So let us say, according to your budget, according to the time available, according to the limitations around, you have decided to survey 1,000 people. Survey 1,000 people. You are doing a research. Suppose if one of you is doing a PhD research, and what is the PhD title? Studying the buying behavior of people in the age group of 25 to 45 in Chennai. And by referring to the literature, you understood that there are 3 million people, but you really cannot conduct survey with all 3 million people. So you decided to conduct survey with 1,000 people, right? And now this 1,000 people is nothing but, you can call them as the sample. All of you understand? First, we talked about population. Another one is, we are now talking about sample. All of you, are you clear with population and sample?
Yes, sir.
Yes, sir.
Yes, right. And now, similarly, in your company scenario, a company can produce, 1 million parts. Possible or not? A company can produce 1 million parts. 1 million parts. And a company has got an order to produce 1 million parts. And this is nothing but population here. This is nothing but population. And the quality department is interested in knowing about the quality of all the 1 million parts that are produced in the factory. But it is difficult for them to check each and every, piece out of the 1 million. So every single day, they might study maybe, 5 or 10 pieces. And that's how they have, the production plan. So now they will just study a small portion of the population. The small portion of the population or a fraction of the population that is considered for study is known as sample in a manufacturing context. Hope it is clear to all of you. What is sample and what is population with respect to a manufacturing context as well as with respect to, the survey, right? Similarly, you can connect it to, in your business also. All right. So now what I do, I stop sharing the screen. Let me take you through the comfortable screen, mini tab, where I can type easily. So we talked about population. We talked about sample. And now, what is your goal? What is your goal? Can somebody tell me now? What is your goal of, data collection and studying everything? Do you want to understand sample or you want to understand population?
So understand the population.
You want to understand the population. In order to understand the population, you are studying the sample. In order to understand the population, you are studying the sample. Based on the sample study, you judge the population. Based on the sample study or based on what you observe in the sample, you judge the population. So this is exactly called as statistics, and very specifically called as inferential statistics. We spoke last week, am I right? Hope all of you remember. We study the population and based on which we understand, we study the sample based on which we understand the population or we judge on the characteristics of the population. This is called inferential statistics. Now, the population has got certain characteristics. How do we call population characteristics? Parameters. How do we call the population characteristics? Parameters. And now sample characteristics. We call sample characteristics as statistics. All of you understand? So the population characteristics are called as, in general called as parameters. But the sample characteristics are in general called as statistics. So with the help of statistics, we predict population parameters, right? So certain example for population parameters. Population mean. Population mean. And similarly, one example for sample statistics. People here, do you understand all the language, all the terms I'm using? This is population mean. This is sample mean. So what is population mean? Generally, population mean is given a symbol mu. Population mean is given a symbol mu, and sample mean is given a symbol x bar. Sample mean is given a symbol x bar. Why do we calculate x bar? We calculate x bar to judge on mu. We calculate x bar to judge on mu. If the number of samples are sufficient, and if the sampling plan is also appropriate, your x bar will become equal to mu. So please confirm, all of you, have you understood population characteristics or the difference between parameters and the sample statistics? Is it clear to everyone?
So could you repeat how mu becomes x bar, on what conditions?
Yeah. X bar can be close to mu if you collect sufficient number of samples. If you can collect sufficient number of sample, your x bar can be close to mu. And one more thing is, your data collection plan should be appropriate. Your data collection plan should be appropriate and adequate. Say for example, the same thing, the Chennai population. So Chennai population example, right? And there are 3 million people you said, and we have decided to have a sample size of how much? N equal to, maybe let us say N equal to 1000. Now tell me, madam, if you are going to judge on the behavior of 3 million people in Chennai, just by studying only 1000 people, how will you collect the data? Or what kind of people you will be meeting? How will you choose the people? Will you choose people only at the heart of the city, or will you spread your study throughout the city? Please tell me. Please give me your option.
It has to be spread throughout the city.
Yeah, has to be spread throughout the city. Why do you want to spread throughout the city? Then only your prediction, your sample study will be close to the population characteristics. Am I right?
It will be representative of the population.
It will be, your sample should be a true representative of the population. In order to make your sample truly represent the population, you are spreading your sample across the population. How the population is distributed, same way you will distribute your sample also. Let us say in Chennai, we are dividing into several parts. Like how do we divide normally? We let us say North Chennai, am I right? North Madras, South Madras, and you can also have all the regions. So 4 different sites, and also you have the central Chennai. Now how many regions? 5 regions. North Madras, South Madras, East Madras, West Madras, and there is also Central Madras. And now you have some clue that people, majority 50% of the people live in Central Madras or Central Chennai, right? And then in North Madras, some 15% of the people are living, right? And in South Madras, another 15% of the people are living. All right. And then in the east, there are only how much? Let us say 10%. No problem. 10%. And then in the west, you have 10%. And now, do you have an idea how the population is spread in Chennai? 50% in the center, 15% in the north, 15 in the south, and 10 each in east and west, right? And now you have to collect the sample. Now tell me, how will you pick up the sample now? How will you conduct the survey? How many survey you will be doing in North Madras? Come on, please. How many survey you will conduct now in North Madras? Come on, it's not a difficult question.
150 if you're calculating 1,000.
15% of 1,000, which is 150. Because you got an idea how the population is spread, and you are trying to spread your sample also in the same manner. Clear? And similarly, South Madras. South Madras is going to be same, another 15%. Then East Madras.
Sir, this scenario, it is dominating for this, the Central Madras, because Central Madras is more majority people.
Okay.
So I think they are dominating for this, if they are higher the buying capacity, it is affecting for the other 3 regions.
Yes, it is. You're right. So I want the same scenario to exist in my sample also, right? So I want to be more realistic. So since the sample is distributed in a particular, population is distributed in a particular manner, I am trying to distribute my sample also in the same manner, so that all my predictions can be more realistic.
Yes.
Right? That is the reason why I'm spreading almost in the same manner. And finally, the central portion. See here, central portion, how many people will come now? 500 people. I will include 500 people for my survey. All 500 people I will preferably choose from central Chennai only, and all remaining. And now there is better chance for my sample to truly reflect the population characteristics. And again within 500, again see here, again within 500, and within central Chennai, and what kind of people, and how many in the age group of 25 to 30, how many in the age group of 30 to 35. The more the idea I have about the population, no, the better will be my sample collection plan, right? So idea about your population, understanding about the population is very, very important to come out with the sampling plan. So ultimately, so what I want you people to understand is, we are calculating some statistics. We are calculating some statistics and to predict the population parameters. We are calculating, I'll write, we are calculating the sample statistics to predict the population parameters. Population parameter can be the average purchase made by people in Chennai. Come on, one of you can tell me what could be the average spending by our what do you say? A person in Chennai in the age group of 45 to 25 to 45. What do you think? How much he could spend in a month? Average spends in a month. How much he could spend in a month? We need to actually, all these statements have to be more specific. I'm just, typing something here. It could be, how much he is spending on food or how much he is spending on entertainment. I need to be more and more specific. Accordingly, the question can be drafted in the survey. So in general, I'm saying how much a person in the age group of 25 to 45 might spend for his family. Can somebody give a figure now in a month?
I think maybe 20,000.
Okay, 20,000 rupees.
But
So
they are earning 15,000.
Yeah, whatever it is, right? So see, we are only talking about statistics. Statistics means approximation. So we are expecting people in the age group of 25 to 45 in Chennai to spend on an average 20,000 rupees per month, right? On an average. And how do you get this number 20,000 per month? Because we observed this thing in our sample. When I raise a question, people have gave me answer around 20,000. So and then I come out with the average, and that has helped me to make this kind of conclusion. And if the population actually has the average expense around 20,000, your prediction is too close to the reality. All right. So now you got some idea, population parameter, and another thing is statistics. Every time you calculate statistics, please understand you are calculating it only with an intention of predicting the parameter, right? And now population data. Population data, when you visualize, visualize means you are plotting a histogram. Visualize means you are plotting a histogram. That visualized histogram.
So the 20,000, how you get this for this value for this, the average value, average salary for all the population or sample?
Okay, it can be better is salary. Let us say salary. See, average salary we calculated from the sample only, because we already know we cannot conduct survey with all 3 million people. So we restricted our study to 1,000, and after conducting the study, we understand that on an average, they either earn 20,000 per month or they spend 20,000 per month according to the question. So it is based on the sample, but ultimately we make a conclusion on the population. Since the sample has reflected, 20,000 earnings per month, we simply conclude that the population is expected to earn 20,000 per month, right? Whether it is earnings or expense, depending on your question. Is it clear?
Yes.
Right. So now, if you visualize the data, you get a graph. Right? And that graph is called population distribution. And population distribution can be normal or non-normal. Please understand. Population distribution can be normal, can be non-normal. Hope all of you agree with me. And now, When I use, see, it is very, very, very rare to have population data in your hand. Very rarely, certain companies might have wealth of data. They, they can only, use this word population data. And population, the distribution of population can be visualized. And now I want to change this. Let me say, this is sample data. What is this? Sample data. I visualize the sample data, and now the distribution is called as sample distribution. The distribution is called as sample distribution. Right? Again, sample distribution can be normal, can be non-normal. Now, one more thing. One more thing. This is, I am going for sample average. Now I am going for sample average. I am visualizing the sample average. I am visualizing the sample average, and now the distribution obtained is known as sampling distribution. Again, sampling distribution can be normal, can be non-normal. How many of you understand my language? I talked about three distribution. One is population distribution. Another one is sample distribution. And third one is sampling distribution. Is that everyone here understood the meaning of all the three distribution?
What is the sampling, sir?
Very good. See here. 1 to 1000. Let us say 1 to 1000 is my sample. It can be, it can be any value between 1 to 1000. Any value. 1, 1.5, 2, 2.5. There are n number of values. This is population. All of you, do you understand population? Yes. And now somebody is collecting 50 numbers. Somebody is collecting 50 numbers out of this population. And now the resulting distribution is called as sample distribution. Right? And now sampling distribution. What is sampling distribution? Somebody is taking 3 samples. Look at the highlighted number. What are the highlighted numbers?
1, 2, 3.
1, 2, 3. Can you calculate the average out of the 3 number? What is the average now? 2.
2.
So this is called sample average. The sample average of 3 samples taken together, or average of 3 samples taken together, is now noted. What is the resulting number? 2. Clear, all of you? Please confirm.
Yes, sir.
Right. Now I take another sample. Let us say 5, 6, 7. Every time my data collection plan is select 3 samples together. Now there are 3 samples. Again, I have highlighted 5, 6, and 7. Now what is the average now? What is the average now? 5, 6, and 7.
6.
6. Same manner, I keep on, collecting samples, calculating sample averages, and now I have n number of sample averages. All of you understand? See, there is a difference in this data, and this data. Am I right? The first one is population, second one is sample, and the third one is sampling distribution. All of you understand what I am telling now?
So I have a doubt here. The sampling distribution can again be random, right? It need not be consecutive. It can be random.
Yeah, it can be random. It can be random.
Can be random.
If you have some idea about how your population is distributed, you can try to follow the same pattern. If you have idea, if you don't have any idea, then it should be random. Like in the North Madras, South Madras, we got an idea that 50% of the people are in the Central Madras. So I will preferably conduct survey. 50% of my survey participants will be from Central Madras only. But if I don't have the idea, then I have to be random, right? Good. So now population distribution, sample distribution, and sampling distribution. Why am I teaching all these things? Please see, we take many decisions using our understanding or using the properties of the normal distribution. Now, if my population is normal, right? There is no guarantee that my sample can be normal. There is no guarantee. If my population is normal, still there is no guarantee that my sample can be normal. But if my population is normal, your distribution of sample average will definitely normal. All of you, do you understand? If population is normal, distribution of sample average will definitely follow normal distribution. All of you understand? This is called central limit theorem. This is called
sir, I need to clear in the sampling distribution that why we are taking the sampling distribution, because population, the sample is we are getting the 15 numbers is enough. That why we have to take the sample distribution.
See, you remember your college days, school days. You when you are doing some experiment in the laboratory, the teacher will ask you to repeat the experiment. Am I right?
Yes.
You will do the experiment 2 times, 3 times, and then teacher will advise you to use the average only. Am I correct?
Yes.
Because your sample average can have this pattern very close to the pattern followed by the population. Do you get my point?
Yes, sir.
Instead of working with individual values, if you work with averages, your predictions can be better. All of you agree with my statement?
Yes. Yes.
So that is why it is always a good idea to work with the sampling distribution and not with the mere sample. This is also the reason most of the time researchers, they go for collecting multiple samples together. Hope all of you again agree with my statement. Even in your company also, every time you go for a data collection, you collect multiple samples together. Am I correct?
Yes, sir.
If you collect multiple samples together, all the sample put together is called as subgroup. All the samples put together is called as subgroup. Suppose if you go and collect 3 samples, then your subgroup size is 3. If you are going and collecting 5 samples, then your subgroup size is 5.
The
Right?
subgroup is we are taking from sample. We are not population, or population we are taking from population.
See, sample is picked up from the population only.
Okay.
But there is when you are collecting the sample, prefer to collect multiple samples. Of course, multiple samples, more samples, it takes more money and more effort and everything. But we want to be more realistic. So take multiple samples. If you take 3 samples together, 5 samples together, then you are defining subgroup size. Let us say your subgroup size is 5. That means what? Every time you go for data collection, you collect 5 samples.
Okay.
You collect 5 samples. But ultimately, how will you use the data? Out of the 5 data, you calculate the average and then use it. Why we need to use in that manner? The tendency of your sample average to follow the normal distribution will be more, right? And that is the reason, because I know my population is normal. I know my population is normal, and so I can go for subgroups, collecting data in subgroups, and then I will visualize the my subgroup average, and that will also follow normal distribution. This is called central limit theorem. If you predict using the sampling distribution, if you predict using sampling distribution, the third one, if you predict using this, your predictions can be much better. Now, one more scenario. My population is non-normal. My population is non-normal. Now, again, I am going for the sampling distribution. Now, your sampling distribution can be normal, can be non-normal. When it will be non-normal? When it will be non-normal? It will be non-normal if your subgroup size is not sufficient. Sometimes people call it in the books, they might even call it sample size. If the subgroup size is not sufficient, even your sampling distribution may not follow normal distribution. But if you gradually increase your subgroup size from 3 to 4, 4 to 5, then what will happen? If with the sufficient subgroup size, sampling distribution will tend to become normal. How many of you understand the theory which I tried to explain for the last 30 minutes? All of you? Or can you please confirm what are the terms we are now familiar with? Please tell me. Are you familiar with the term population?
Population, sample.
Sample.
Subgroup.
Subgroup, very good.
Population parameter.
Population parameter. Then sample.
Statistics.
Sample statistics, right? So population parameter you understood, sample statistics also you understood. And all of you, do you understand sampling distribution? What is sampling distribution?
We are taking from the average.
Very good.
From the
Let's say you are producing a product, the requirement is length should be 100 mm. What is the customer requirement? 100 mm. So that means, what is the population parameter to be? What is the required population parameter? The length must be 100 mm.
100
mm.
Yes.
And now every shift, there are several thousand units are getting produced. And now you are collecting sample. Let us say every 2 hours once or 3 hours once, you are collecting samples. You will take multiple samples, isn't it? Let us say you are taking 3 samples at a time. Every 1 hour you are going and you are collecting 3 samples, right? And first sample, the dimension is 100.2. Second sample, the dimension is 100.4. Third sample, the dimension is 99.8. All of you, do you understand?
Yes, sir.
First hour you have taken this. Now again, this is actually subgroup 1, right? This is subgroup 1. And now after 1 hour, again you are taking 3 more samples, right? Again you are taking 3 more samples. Another 3 samples. Now this time this can be little different. I'm only making some assumptions here. It can be even 99.2 or something. Now my point is, if the population, this data length is actually a continuous data. Please understand. Length is actually a continuous data, and the length of any product will follow continuous distribution. Length of any product will follow continuous distribution. If you visualize, after collecting some sufficient number of samples, if you visualize, you will be able to accept it. And now the sample average, the first sample average. How much is the first sample average? Let us say approximately 100.25. Second sample average, this may be 100.15. If I take 10 subgroup, I will have 10 averages. Am I correct? 10 subgroup, I will have 10 averages.
Yes.
Now, what will be the average of averages? The average of averages will be close to 100. The average of averages will be close to 100. So the point here is, if you make your predictions based on the sampling distribution, you will be able to get a realistic estimate of the population parameter. So that is the reason why most of the time we collect data in subgroups. We collect data in subgroups, and then your prediction can be better, right? So now let me take some data. Let me collect some data. Weight. And now there are 10 people here, right? So Shafiullah, can all of you can you give your data about your weight? Let us check whether how the data is. Shafi, will you be able to share your weight in kilogram?
Sir, last week I checked 85, but now 87 it will come maybe.
Whatever. Okay, no problem. It's only approximate value. I will also give my weight, right? Don't worry. I'm 73. How about others? People can share. Let us see.
65.
Okay, you're 65. Then Rushikesh, Kiran. Yes, all of you just tell your weight. Let us see how.
75.
Okay, 75. Then we are now trying to judge on the distribution of weight among people who are studying Six Sigma, right? Six Sigma black belt program or something. Yes, all of you just give me your numbers. You don't want to share? So let me make some assumptions here again. So 74. See, always, if you actually collect the data, then only, you will be able to connect the theory well. So I'm just typing randomly something. Okay. So I have about some 10 data. And now what is this data? Can somebody tell me? Is it a sample data or a population data or a sampling data?
This is a population
data.
What is this? Population.
If you're considering the classroom, yes, it is a population.
Classroom total.
Yeah, if there are only 10 people who are studying and you have the data of all 10, then it is population. I agree, right? But you all know it is not, our batch, we have about 30 people, right? But then how many data we have? We have only 5. Sorry, we have only 10. So what is this actually?
Sample.
Sample. Very good. And now I'm going to show you the sample distribution. How the sample is distributed. Sample distribution. Let us see. So go to graph. There is a histogram, right? Go to graph, histogram. Histogram of weight. Okay. Can you all see how our data is distributed? How our data is distributed? Do you get an idea? Can you comment about this graph now?
Average is big size.
Average weight is 75, isn't it?
Yes.
The sample average is 75. But what is my interest is, I want to actually note down the weight of all 30 people who are studying in the class. And my prediction of 75 as the average, is it really true for my population? Right? And right now I am working with sample data. Right now I am working with sample data. Right now I'm working with sample data. But your prediction can be better if you work with sampling distribution. Hope people here know the difference between sample data and sampling data, isn't it? Sampling distribution means every point is an average. See here, every point is the data. Suppose, so this is sample. Forget about the weight example now. Let us assume it as a length or something. This is sample. Now sampling means this will be an average of 2 or 3 samples. Am I right? Average 1. And this will be average 2. This will be average 3. Which one can lead to a better prediction? Sampling distribution can lead to a better prediction, right? And particularly when population is normal and you are working with sampling distribution, your prediction, will be much better. Your prediction will be much better. All right.
But how to calculate, sir? It is average value for the add all the value and divided for the numbers.
Yes, yes.
Correct, yeah.
Say for example, this is my first subgroup.
Yes.
Right? 87 and 73. So my average will be, average of 87 and 73 will be 80 only. First average. Clear?
Yeah.
So the first two, suppose if this is my first subgroup and first subgroup average is 80. And now next set of two is 65 and 75. Now what is the average? 65 and 75? That is 70.
Oh, sorry. Yes.
That is 70. Now third set, 74 and 68. 130, 142. So average will be 71. Right? And now fourth set, 85 and 79. How much this will be? 150, 164. 164 means
Yes.
average will be 82.
82.
Now finally, 77 and 74. How much it is? 140, 151. 151 means this will be 75.5.
Yes.
Now let me visualize this. This is sampling distribution. Sampling distribution. Let me visualize this graph. But see, the data I used is, very little. So I should have sufficient data. But anyway, I'm just trying, to just for illustration purpose. And now this has actually become uniform. What is this distribution you are seeing now?
Sampling distribution.
Uniform. This is not normal. Normal means there will be a peak happening in the center. This has actually, become a normal. You know why? Because every value appears only once. Can you see that? Every value appears only once. If I add some more value, let us say, 70 to 80, 75.2, now it will become normal. 75.3 and 76.8, 71.2, some value. Now I have added, few more values. Graph, histogram, simple, and now column 3. I'm visualizing. And now how it is appearing now? It is now more or less normal. It is now more or less normal. And now see here, the average is now coming out to be 76. So the 76 can be a better estimate of the average age of the, average weight of the population. So, but what is very important is quality of data. Right now, our data quality is very poor because simply I'm typing. We need to have the real figures so that it can speak better. So I'm again.
The histogram is it is middle value. It is higher. Not for higher value, it higher. Correct?
No. See, histogram is nothing but a kind of bar chart only. See here, but your data type should be continuous. Histogram looks like a bar chart, but look at your x-axis. What is represented in the x-axis? The weight of the individuals. Weight is a continuous data, right? And then the y-axis talks about frequency. What is frequency? There is only one data that is having a value of 70. But 72,
Okay.
how many data? There are 2. 76, how many data? There are 4. So this kind of arrangement of information is known as histogram. And now you get an idea of the shape of the distribution.
Okay.
Graph, histogram. Even you can, you can also choose the second one. Give okay. Now you will also see, how the distribution is actually coming out. The graph also will be drawn. You can understand now. It is close to this data can be assumed to be a normal distribution like this. So that is the understanding, right? So now let me open project data now. File, open worksheet, sample data folder. I am just opening something here, camshaft. Look here, now this is a project data. Now this will work very well. And now can all of you understand? Now there is a lot of data. How much data we have? 100 data. 100 data I have, right? All these 100 data talks about length of a product. All these 100 data talks about length of a product. And now these data belong to supplier 1. This data belong to supplier 1. And this set of data belong to supplier 2. Let me see how the data is distributed for supplier 1. Graph, histogram, simple or with the fit. Okay. And now supplier 1, I am double clicking. Tell me how the data is distributed.
Normal.
Normal.
No.
So this is normal, and now your prediction can be easier. And now you understand the length of the product ranges between 598 and 601, and majority around the average. A small fraction on the left extreme, a small fraction on the right extreme. All the understanding about your normal distribution, you can use it now to make predictions. What percentage of the population can be in the central range, and what percentage can be within your control limits, and all those comment you can now make, because you have seen for yourself that your data is following normal. If the sample is following normal, and you can predict about your population using the properties of the normal distribution. Similarly, if I want to plot a graph for supplier 2, how should I do it? Can somebody help me with the steps now? Graph and then
Histogram.
Then with the fit,
with
or the simple one, both can do. And then I give OK. And now instead of supplier 1, I am going for supplier 2.
Supplier 2.
Okay.
Okay.
And now the supplier 2 is maintaining this level of quality. What is the average maintained by supplier 2? 600.2. What is your company's requirement? 600.
100.
And now supplier 2, we understood. Supplier 1 also, let us have a look at supplier 1. Supplier 1. And tell me, what is the average of supplier 1?
599.5.
Now tell me whom you can rely on, supplier 1 or supplier 2?
Whose the standard deviation is
Supplier
low?
2 is close to 600, right?
Yes.
2 is close to 600. But however, in terms of consistency, supplier 1 standard deviation is 0.6. But supplier 2 standard deviation is 1.8. So who is more consistent?
Supplier 1.
Supplier 1.
Supplier 1. In terms of consistency, supplier 1. But if 599.5 is okay for you, then you can make a conclusion. Yes, supplier 1 is better than supplier 2. And again, if you want to make a solid decision, then that leads to a topic called hypothesis testing. Who is better? Supplier 1 is better or supplier 2 is better, according to the data that you have. That's exactly called hypothesis testing. That is in fact called as 2 sample t-test. We have supplier 1 data, we have supplier 2 data. All right. So this is something I wanted to show. And similarly, when I look at the Excel sheet, yes, this is the Excel sheet. And now I mix up the data I collected from supplier 1 also, supplier 2 also. When I mix up the data, this is not a good idea actually, please understand. We should not unnecessarily mix up data, because when I mix up data, I am mixing 2 population. I am mixing 2 population. So let us see, when after mixing up the data, how my distribution is appearing. Graph, again histogram with the fit. And now let me use this mixed up one. And look here how your distribution is. This is not normal, isn't it? So this can happen actually. So without any logic, if you mix up the data, and probably your distribution will get affected, and then all your predictions might go in a wrong direction. So that's why we should have some idea about where from we collect the data, and accordingly we should analyze. And now anybody would like to try in Minitab? Are you ready? Maladi madam, are you ready with your Minitab software?
It is not working, sir. Actually, I'm not able to connect to my laptop. So
and who else is ready? Anyone is ready with the Minitab install?
Yes.
Safi?
Yes, sir. I am ready.
Yeah, you please share your screen. You can share your screen. And now you can do it yourself, right? So now go to file. Go to file. File, open worksheet. Open worksheet. Open worksheet. Come down, come down. And now can you click this icon, that Minitab file icon in the bottom? Look in sample folder in the bottom,
The bottom of.
you click
Okay.
that once, you click it. And now in the file name, you type CAM. In the file name, you type CAM. CAM. You can second one, camshaft.
Okay.
Camshaft, not the camshaft 2.
Okay.
Camshaft, right? This is a inbuilt project data for practice purpose, right? You click open. Click open. Okay. And now you got the data.
Yes.
Right? And now you want to visualize, right? And now supplier
Yes.
1. Now let us visualize for supplier 1. Go to the graph. Go to histogram. With fit or without fit. Okay, you are gone for simple. Now supplier 1, double click. Yes, give okay. And now you plotted a histogram. Now you plotted a histogram and visually you have understood that the data is normally distributed. It's a visual confirmation.
Yes.
What is this confirmation? Visual confirmation.
Yes.
If you want to know how what kind of distribution will best fit your data, you can simply plot a histogram and understand. Right? But most
so
of
we have we have to try to the normal distribution for all the samples. We have to make the try to on normal distribution, right, sir?
If the data follows normal distribution, then situation is very, very easy to handle. Right? Very, very easy because we know more about normal distribution, isn't it?
Yes, sir.
So try your best to make sure your data follows normal distribution. Suppose if the data is not following normal distribution, please move from sample data to sampling distribution. You understand?
Yes, sir.
If your sample is not following normal distribution, instead of collecting the sample, start collecting samples in subgroups. Clear? Clear, everyone?
Yes, sir.
Start collecting samples in subgroup. Your subgroup size can be 2. Subgroup size can be 3. Subgroup size can be 4. But don't use the data as it is. What should you do? For every subgroup, you calculate average. For every subgroup, you calculate average. If there are 100 subgroup, then how many averages you will get?
50 average.
100 subgroup, I told you. Every
So
subgroup
100
average. Now visualize the 100 average. Visualize the 100 average. The visualized distribution should be called as sampling distribution. If the sampling distribution is normal, and you can start prediction. You can start making conclusion. If the sampling distribution also is not normal, how will you handle the situation? One more option you have is increase your subgroup size. What should you do? Increase your subgroup size. Earlier subgroup size was 3 and now try subgroup size of 5. If you gradually increase the subgroup size, definitely when the subgroup size is around 6 or 7 or 8, close to 10, your data will tend to follow normal distribution. This is a theory. This theory is called as, what is the theory I told you? Central limit theorem. This will hold good in all business, any kind of data. So literally, any problem in the world can be converted into a problem in normal distribution. That is the advantage of understanding normal distribution. Any problem, whether your population is normal or population is non-normal, don't worry. You don't know anything about population, but you want to understand the population. Now, what is the best distribution you should work with? Sampling distribution. How to create a sampling distribution? You must collect the data in subgroups. And gradually increasing the subgroup, you will see your distribution becoming normal. Right? If it becomes normal, and you can start making your conclusions, right? So now that I think, Safi, you are now able to plot the histogram for supplier 1. And now just do it for yourself, supplier 2. graph, histogram with fit now and supply to. This is also normal, right? This is also normal. So this is how you can actually plot histogram, and you can plot histogram for any data. What should be the data type? Data type must be
It is normal.
Continuous.
data type must be continuous. And now tell me, what is continuous data?
Anything
What is
that is
infinitive?
measurable.
Anything which has
Measurable data.
measurable.
Measurable. The definition is measurable. Anything that is measurable. Anything that has a unit of measurement. Length has a unit of measurement. Am I right? Millimeter, centimeter, kilometer. If it has a unit of measurement, that means the data type is continuous.
Continuous.
Hope everybody is clear, right? Then what is the definition for discrete data?
Which can be counted. I mean, the
Countable.
data can be countable data.
Countable. And if you consider a continuous data, let us say I expect my data to fall between 10 and 15. I expect my data to fall between 10 and 15. Let us say my data is about temperature. Temperature can be anywhere between 10 degrees Celsius and 15 degrees Celsius. Now tell me, how many possible values are there between 10 degrees Celsius and 15 degrees Celsius?
It is continuous data, infinitive.
Infinity. That is, infinite values are possible. That is why we call it continuous. That is why we call it continuous. Countable data. Let us say number of televisions in your house. Number of televisions in your house. What kind of data it is?
It is descriptive data.
Discrete
It is
data.
discrete, because number of televisions you can simply count. In my house, I have 2 televisions. Some of you might have 3 televisions.
3.
At the maximum, some people might have 4 televisions. Some people might have only 1 television. And there is also a possibility that people may not have television at all. Am I correct?
Yes, sir.
Now, how many possible values we have come across now? 0, 1, 2, 3, and finally 4. So how many possibilities?
Like 3, 4,
5.
4.
Only 5 values are
5.
possible. If you conduct a survey about number of televisions people have in their house, the outcome or the data can either be 0, 1, 2, 3, or 4. Nothing outside and nothing in between. 1.5 it is not possible, isn't it? So
Yes, sir.
number of possibilities are finite, or number of possibilities are discrete. And that's why we call the data as discrete. Is that clear to everyone?
Yes, sir.
Yes, sir.
Continuous means measurable, discrete means countable. Most of the time, discrete is whole number. Most of the time, the discrete is whole number.
Whole number.
Continuous can assume any possible value. It can be decimal to any number of digits, right? But this understanding is very, very important, and you can expect the normality with the continuous data. You can expect the normality with the continuous data. So whenever you want to make better prediction, you must rely more on continuous data. Wherever possible, try to collect continuous data. Try to collect measurable characteristics, right? Because the discrete data will have certain limitation. And so continuous data is the gold mine for Six Sigma experts. All right. So just one more quick thing about what we discussed, what we learned last week. I think, Safi, you remember we studied about the probability rule and other things, right? Normal distribution, probability calculation. Do you remember probability distribution we spoke about? Safi?
Yesterday, last week, sir. Last week.
Last week I spoke
yes,
about
yes.
probability, right? So
Yes,
just
yes,
go
sir.
to just go to graph. Go to graph. Go to graph. Go to probability distribution plot. Go to probability distribution plot. Come down. Probability distribution plot. And now go to view probability. View probability. Give OK. Now normal. No, wait. You don't have to plot anything. Just go again. Graph. No, leave it. Let it be. No. Yeah. Graph, probability distribution plot, view probability. Okay. Okay, wait.
Yeah, oh,
And now, one of you, can you tell me a scenario, right? Suppose when you have studied your college or school, what is your average, mark scored by you? What is the average mark you normally score when you studied college?
60 to 70%.
Okay. Average, 60 to 70 means 65 and Shekhar says 75. Okay, we will use some value. Type your average mark in the mean. Average mark in the mean 65.
75.
Okay, 75. It doesn't mean that in all the exam you have scored 75, isn't it? It will be
Yes.
75 plus or minus. And that is why we require standard deviation also. Let us say you always have 75 plus or minus some marks, and let us assume the standard deviation to be 5. Type standard deviation to be 5. So what are we saying? Our Shafiullah's test mark, average test mark of Shafiullah is 75, and standard deviation of the test marks of Shafiullah is 5. And now, what is now next month? Shafi is going to write an exam. Next month, Shafi is going to write an exam. How much mark Shafi can score? That is what I want to understand. Now, shaded area. Click shaded area, top. Yes, click that. And now I want to understand what is the probability for Shafi to score between 60 and 90. All of you, do you understand? I want to understand what is the probability for Shafi to score above 60, And Shafi, can you see one graph, which is highlighted in black, right tail?
Right.
Already
Yes,
it
sir.
is already highlighted.
Yes, sir.
That gray area indicates area above a specific point. Now you click X value, click X value. And in that X value box, just below the graph, you type 60. There you type 60. If Shafi gives okay, now Minitab will give you probability for Shafi to score 60 and above. Can we see that? Give okay. What is the probability for you to score 60 and above?
Yes, it's 100%.
Close to 100%, because
Yes.
his mark is 75 and his standard deviation is just 5. Now I am 100% confident, to be very precise, 99.87% confident that Shafi will score above 60. Now repeat the same thing. Go to graph, probability distribution plot. Go to graph, probability distribution plot. And now let us change the mark and let us see the different possibilities. View probability. Okay. And okay. And now go to shaded area. No. The same thing will come. Again, go. Let it be. Graph, probability distribution plot, view probability. Okay. Go to shaded area. Now change your mark. Instead of 60, you make it 75. Now Shafi has to score 75 and above. What is the probability? Give okay.
50%.
All of you, do you understand? Because 75 is his average mark, So there is 50% chance for Shafi to score above 75 in the upcoming exam. Please understand. Now, people, when you are making prediction, you should have an idea about your sample and your prediction. What is our sample? The exams that are already written by Shafi. What is our prediction? The exam that he is going to write in the near future. If the exam is same, then predictions can be very close. Am I correct?
Yes, sir.
If whatever exam he has written already is completely different, and the exam he is going to write in next month is completely a different subject, then the prediction is a bad prediction, because my data is not a representative of the population which I am trying to predict. Hope people here can make out. And now you can find out probability for any event that can happen according to the data you have collected. Now you can once again go to graph, go to probability distribution plot, go to view probability. Okay. And now, and now go to shaded area. And now same thing, right? Choose the last option, middle, yeah. And now, what is the probability for Shafi to score between, let me say, 62 and 72? X1 is 62. X1 is 62. X2 is 72. Give okay.
It is quarter, I think.
All of people here, are you able to understand how all these calculations are working? 26% chance is there for Shafi to score between 62 and 72. How do I make this statement? Depending on certain data I have about Shafi, isn't it? Similarly, if you collect some sample from your business process, you have certain information. Information means you have sample average, you have sample standard deviation. If you have sample average and sample standard deviation, you can better predict, the population characteristics, provided your sample as well as the population follows normal distribution. If both of them follows normal distribution, your prediction, will be very, very close to reality. If the distributions are different, your predictions can go wrong. That is why we always try to make our data follow normal distribution. For that, we use different sampling technique. The alternate method is to learn about other possible distributions. And then, the subject will become very vast. You can't master everything. Hope all of you agree with me, isn't it? So just master the normal distribution and try to convert every problem into a problem, representing the normal distribution pattern. All right. How to fix the standard deviation? Fixing the standard, see, we are not fixing standard deviation. We are only calculating standard deviation. How do we calculate standard deviation? From the sample data. You have collected sample and now use the sample and calculate the standard deviation. And that's how you get it, right? And then if you really wanted to reduce your standard deviation, can somebody answer this question? If I want to reduce the standard deviation, what should I do?
We have to close the target.
I have to make some meaningful changes in my process. Am I right? I have to make some meaningful changes in my process. Then only, the standard deviation can come down. Say, for example, I want all of you to score, mark around 80. I want full consistency. Everybody should score, around 90 or around 80. And now standard deviation should be less. That means, I really have to work hard. My process, should not allow any room for variation. Everybody should get same kind of input, same kind of material, and everybody participate in all classes, and then only, the variation can come down. So you need to make some meaningful changes in the process, and thereby, the standard deviation can come down. So that, as we progress, you all will come to know. So any specific question anybody would like to ask before we wind up for the day? So few things we learned: population distribution, sample distribution, and then sampling distribution. I think all of you here are able to, differentiate the three.
Yes, sir.
Population distribution, sample distribution, sampling distribution. And which has, more chance to exhibit normality? Sampling distribution. So that is why it is important to collect sample in subgroup. Subgroup size can be as low as 2, and it can be as big as 25. Definitely, in my opinion, if you change your subgroup between 2 and 25, definitely, you will start seeing the normality. You can try out And for that, you should look for some real data. Simply, if you type some number and try, and that may not happen, you should actually go for real data. So that is one thing we understood. And then the sample characteristics. Sample characteristics are called as statistics. Sample characteristics are called as statistics. And population characteristics are called as parameters. Ultimately, you want to understand the parameter. How much is that people on an average make as they earn? People in Chennai, people in Mumbai. That is what I want to understand. But I really cannot go and ask everybody. So I will only collect some data from a sample, and based on the sample average, I will try to predict the parameter. So may we calculate the standard deviation with the Minitab? Yes, why not? Okay, Shekhar Dina asked. So Safi, please go to stat. Since our Shekhar want to calculate standard deviation, go to stat, go to basic stat. Stat, basic stat. Choose display descriptive statistics. And now, for which data we need to calculate? Let us calculate it for supplier 1. So select column number 2. Select, okay. Now click the button statistics. And now first you click none. Click none. Click none. None. In the bottom, none. Last option. Just above last option.
Okay.
None.
Okay.
And now Shekhar Dina want to calculate standard deviation. Can you find standard deviation? There are so many statistics available. Where is standard deviation? Click that. Give OK. Give OK. Once again OK. Once again OK. How much is the standard deviation of the
0.6.19?
Whether the column contains 100 data or 1 million data in a fraction of a second, you get the standard deviation. Suppose you want to calculate everything. Go to stat, basic stat, descriptive stat, and okay, the same data, click the statistics, and now instead of none, you click all. Click all. Give OK. Once again, OK. Now everything is in front of your table. Now everything is in front of you. Can you see? So many statistics. But what is that you want to use? Why are you looking at all these things? Can somebody answer this question? Why should we look at all these things? We want to
understand the population.
That's all. To understand the population parameter, we are looking at the statistics. And similarly, to make conclusion about the population, we need statistics. And with the help of mean and standard deviation, you can figure out the probability for any specified interval. You can figure out the probability for any specified interval, right? So I think this is some tough stuff for all of you today. Hope people have understood to a certain extent. If you have understood everything, then that will be a great scenario, right? Shall we close the meeting?
So I have a question. I was just going